Hey, thanks. So we'll get started here. So imagine the scenario. Your organization is hit by some e-crime group. They drop ransomware in your environment and encrypt everything. A business comes to a screeching halt. Your team works all night, and you've gotten them out of your system, so you're all good there. Leadership says that ransom payment is not an option, so you've got to restore your data and do it pretty quickly. You get to your backups, nothing. They're not there. You can't see the servers. They're completely inaccessible. They can't be seen. Your most important data can't be accessed. The backups are supposed to be immutable. So business can't continue. Your boss is breathing down your neck. Customers are starting to panic, and Krebs starts calling. So what are we going to talk about today? Immutable backups and what they are, how they work, some concepts around them, some vendor case studies for what we tested, recommendations, and why you might want to include that in your testing. So who am I? I'm Ryan Kane. I work at Northwestern Mutual about 9 years. Pen tester, red teamer. I used to be a developer in a previous life, and I've been a volunteer at the Lockpicking Village here at CypherCon since the beginning.
And I'm Rushank. I work with Ryan at Northwestern Mutual, where I do pen testing, red teaming, purple teaming, and some security research. I've been a long-time lurker at conferences, and this is me first time presenting at CypherCon. All right, so why are immutable backups important, and why did we choose to look at them for security research? Well, because threat actors, especially ransomware groups, are already actively targeting data backups to force organizations to pay them. If an organization is not able to recover from a ransomware attack because they can no longer access their backups for disaster recovery operations, then that makes them more likely to pay that ransom. So, for example, let's take an example out of CrowdStrike's recent threat intelligence report, where they mentioned the threat actor known as Alpha Spider, which is known to destroy an organization's backups using techniques like disk wiping and deleting Azure computed snapshots. All right, so moving on to our glossary, or let's say talk about concepts. What is data mutability, and how vendors have some certain terminology associated with them. So the vendor devices that we're going to see are also known as worm devices, which stands for write once, read many. What that means is once a data set is written onto those devices, they are marked as read-only from there on. And the way that happens is through a retention lock or a vault lock. What that means is once the data is marked as read-only or marked as immutable, it is set for a certain amount of time. So in our case, while we were testing it, we set it for like 2 weeks. But on one of the vendors that we picked up for our case studies, we saw that they had an upper limit of like 7 years. So you can actually make your data immutable for like 70 years at a time. And when it comes to industry standards, there are 2 ways you can make your data immutable. One is governance mode, and the other one is compliance mode. Governance mode is the less stricter one. So if you mess up or you want to unlock your data earlier, you can when certain conditions are met. The other one, the stricter one, which is what you should be using if you do end up going down the route of immutable backups, is compliance mode, where if you set your data set to be immutable using compliance mode, even root or super user or admin privileges cannot unlock that data. Once that data is locked, it's going to be immutable for the rest of the retention period. And yeah, you can't touch it. So why is immutable data important? Well, because let's say you get hit by a ransomware attack, or so in that case, as an organization, you want your data, you want to recover from that attack. And for that, you need something that's read-only, that's immutable, cannot be modified, even by threat actors.
So why was this testing needed? Well, we have some solutions in our environment that are immutable backups. If we, as a financial organization, are hit by ransomware, we have been targeted. It's common that they're targeting financial institutions. We need to make sure that our backups are protected. So our expectations going into this were that, well, we're going to make sure our backups are protected as much as possible, that they can't be destroyed, they can't be touched. And we needed to learn. We needed to learn all these concepts because this was new to us. We've heard these concepts before, taking the CISSP, but this was really new from a testing perspective. We thought we might be able to attack the immutability, but that seemed pretty futile because these solutions specialize in immutability. It doesn't really make sense to target that directly. Instead, we figured, what if we attack the servers or the infrastructure around them? Because if you can't get to your data that's supposed to be immutable, then maybe it's not really immutable. So the solutions that we tested were Dell EMC's data domain, IBM's DS8000, and AWS backup. The two first ones are physical appliances. They're giant machines that go in your data center, handle the backups, send them off to some other system, whatever. I'm not sure how that works, but they're physical appliances in your data center. The other, obviously, is in the cloud, is AWS. So the first case study is Dell EMC. Their product is Data Domain OS, DDoS. It's really called that. They use compliance mode. They call it retention lock compliance enabled. It's not that important, but that's what they call it. But that way we know that it's going to be locked. And in the case of our test environment, it was going to be locked for 2 weeks at a time. The files that we were going to be hitting were going to be locked for a minimum of 2 weeks. So the environment runs this DDSH, data domain shell, that's just like a Linux environment, but it's very locked down, a few dozen commands at best. It's jailed, so you can't do anything outside of their prescribed commands that are allowed. And you can access it through SSH. So, kind of like Linux, but very, very locked down. That handles a lot of the backup infrastructure, who can access the backups, where they go, when they get backed up, things like that. There's an SE mode, system engineer mode, inside DDSH that you access through a command in DDSH that gives you the serial number of the machine. You access SE mode, it asks for the serial number, you paste it in there, and now you're in SE mode. There's probably only certain users that can access it, but that's going to handle a lot of the system level infrastructure, maybe your LDAP connections, your SSH, things like that. So there's going to be some overlap, but from what we could figure out, that's a rough layout of how things worked. The way we accessed it was through vaulted AD accounts. They granted us access to their vault in the test environment. They were AD accounts. They had admin access, but that's what we were given. There were local accounts as well, root, sysadmin, secuser, and ddboost, and we'll get into those in a little bit. There's also a bash shell, but you couldn't enter bash shell without having a key. And I will show an example of that here. So in the screenshot above, you're logged in as sysadmin. You try to enter bash, system bash enter. It will require credentials of another user with a security role, in this case, sec user. So even with both those credentials, you can't get into bash without this DD support key. You have to be on a call with Dell, and they give you a key, and it lasts for 4 hours, lets you into bash. But there are other commands that require both of these sets of credentials. So more high-level security-related type activities or commands will require both sets of credentials. So it's a lot like the scene in war games where both people have to agree and turn the key at the same time to launch the nukes. In this case, sysadmin and sec user, or people with those roles, have to agree and both log in at the same time, use the credentials at the same time. If you're a sysadmin and you try to perform some action and you can't get sec user to agree to what you're trying to do, you might have to use some friendly persuasion, but just depends. So after spending a bunch of time viewing options inside the application, inside the shell, viewing the help screens and reading the documentation on Dell's website, running into failure after failure, trying to overwrite data even though we knew that wasn't going to work. We tried to unmount the DDFS, the file system, didn't let us do that. We tried to spin up a rogue NTP server, which is the time server. we thought if the files are locked for 2 weeks, let's tell the system that it's actually 2 weeks in the future or a month in the future. Then the files will be unlocked and we can delete them. They'd thought of that, and they'd only let us change the server 2 hours at a time. So we could only do that in 2-hour increments. So if a file is locked for a year and you can only change it 2 hours at a time, it's just not feasible. There's not really a way to script that because you're in the DDSH that doesn't have a scripting feature that we could find. Eventually, on some knowledge base article or some public forum, somebody asked a question. They mentioned this registry command. It wasn't in official documentation. We couldn't find anything about it, but we found out you could just run reg show config, and it would just give you hundreds and hundreds of configurations inside the system. Some of those happen to be cron jobs, and we saw they were running as root. When we tried to change one, you can see from the shot above, we ran a reg set config on that DB handler configuration, ran as root to touch a file that we were locating in a local user's home directory, the local user that we created. After about a minute, the file showed up. So now we knew that we could control commands on the underlying operating system, and looks like it could be done as root.
All right. So we have enough privileges to run a cron job as root user, but just touching a file to disk is not enough, right? That doesn't get us anywhere, other than just confirm our theory that we can indeed run commands as root. So we used SE mode, and we targeted the same cron job again, DB handler. And in this case, we just grabbed the simple reverse shell payload you can get from payload, all the things. And the only note of here, if anyone has not worked with cron jobs, is the 5 asterisks. That just basically means run this cron job every minute. The second part is root. It says run this cron job as root user, and then bin bash with interactive flag, connecting back to an attacker IP, an attacker port. On our attacker machine, we are running a simple netcat listener, and that's it. And what it looks like, unfortunately, we can't actually have a demo because these are real machines, right? We can't connect to them outside of corporate VPN. But this is what it looks like. On the left-hand side, you have the DDoS server, where you're running that malicious cron job or setting the malicious cron job. And on the right side, you have your attacking machine, where you're catching the reverse shell. Two things to note over here. In the reverse, when you catch the reverse shell, the first one is, as you can see, it says bash 4.2, indicating that now you're successfully broken out of Dell's jail shell, right? So you no longer are restricted to the 15 commands that they have that do nothing for you as an attacker. And secondly, it's running as root. So now that we have completely pwned the box, right? We have root privileges. We have broken out of the jail session. We attempted destruction of the immutable dataset. We did revisit some of the attacks that Ryan mentioned in his discovery phase. Two of them are notable. The first one is overwriting immutable dataset. So now that we have bash mode enabled, we use the DD utility, and you can just point it to like something like dev null or dev random, and point the output file to the immutable dataset on disk. But well, the data was in fact immutable because we couldn't do anything with it. It just didn't overwrite it. And the second thing was, the DDFS file system. So we identified the exact mount point for that immutable dataset. In this case, it was a proprietary file system. They call it DD file system or DDFS. And even though we dropped the file system, we used a separate backup and restore application. In this case, it's Veritas Net Backup. And we tried to use that box for recovering the last known good data set. And for some magical reason, it still worked, even though the file system was unmounted. So that was weird. But from this point, we realized that, hey, okay, this data is truly immutable, or we just don't know enough about it to attack it because it's a closed system. So instead of that, we thought about how else, as an attacker, thinking from a ransomware threat actor perspective, how else could we attack this box or ransom this box? And that's when you realize that we should probably go after either cutting off the access to the legitimate access to the box so that legitimate users, sysadmins can't log in and undo our malicious changes, or try to attack however this net backup box was communicating with this DDoS machine. So so that's when we realized that the DDoS machine uses something called as a DD boost protocol. That's the protocol that shares with NetBackup to restore the DDoS machine. And what is DD boost? Well, DD boost is Dell EMC's implementation of NetBackup's open storage API, which allows these competing vendor solutions to talk to each other. And for DD boost to work, a local user account has to exist on the DDoS machine. So to prevent NetBackup from restoring the DDoS machine, we just use a simple sed one-liner to delete the local DDBoost account's password hash from etc shadow, which effectively deletes the user. And we could do that because, again, we are the root user. And to ransom the box further, we also deleted the LDAP connection to prevent a powerful domain account like a domain admin logging in and undoing our changes. And as a result, two things happened, right? First of all, that machine the immutable data sets on that machine could no longer be used by restore solution like NetBackup or any other vendor solution, effectively killing that process, right? So that box is useless for disaster recovery. And also it prevents a legitimate user from logging in and undoing our changes. And this is what it looks like from a demo perspective. That's us running our sed one-liner with a D flag, looking for pattern DD boost and nuking it from etc shadow. And the second screenshot is that of the command line from NetBackup, where where we are querying the status of the data domain servers. And as you can see, the server with the octet 06 is marked as down because the user doesn't exist anymore. So NetBackup can't talk to it.
So this was reported. This was reported to Dell, and they fixed it as part of this DSA. The fix was to deprecate SE mode, so you can't enter SE mode anymore. So right now we can't change or exploit the cron jobs like we did before, and the shell is even more locked down than it was previously. We didn't go much further than just a simple validation, but it doesn't mean that maybe there's not a way to still exploit this. But just from a quick validation, SE mode is gone. The cron jobs that we exploited before were also not able to be changed. Our next solution was IBM. The IBM system is DS8000, runs on a huge appliance called the DS8000 solution, but it's made up primarily of these three applications: HMC, DS8000, the application itself, and CSM. They're all on the same physical hardware, and they run the same underlying operating system, probably Red Hat of some sort. The environment that we were provided was URLs only to those applications, no access, so we were not given accounts of any sort, and this was production. So if we could access it, if we could get into it, we couldn't break it, we couldn't make any changes, and we had to be really careful. This felt like a web test and not really a test of immutable backups and to make sure they were secure. It kind of felt like it was out of the spirit of what we were trying to do with testing immutability. We complained to our leadership, and they told us, "We'll give it your best shot." Okay, fine. All right, we'll do that. 5 minutes later, we were in his root with default creds. So, and these are some of those creds. I hope we don't get sued. Anyway, so, right. We had default credentials for 2 of the 3 applications. Our ultimate goal was to access CSM, but spoiler alert, we couldn't do that. We spent a lot of time looking for ways into the system, trying to get shell on the box, do anything we could. We couldn't do that because nothing we did could be persistent. We couldn't make any changes that might last. This was production. We couldn't cause any real outage if it was that sensitive. Why are we testing it for persistent or for immutability? I don't know. But yeah, so we couldn't really do anything. We had to just learn by seeing what was there. We had 4 findings that we reported to IBM's PSERT, their product security team. The first is this. In the hardware management console, the HMC login screen, if you were to use one of those default creds of the CE account, it would pop up the CE is not allowed to log on remotely. All right, great. They enforce that by disabling the logon button. I think you can probably see where this is going. Using your, lead hacking skills, you open developer tools, you delete the disabled flag. Now you're in as CE. So cool. This is what HMC looks like. I'd love to show you more, but there are hundreds and hundreds of sub-menu options in here. It's huge. We spent all of our time, well, I spent a lot of my time looking through this system, just trying to see what was there, what might be interesting that we could do without making a change. Wanted to enable SSH. We weren't really allowed to try that, so there wasn't a lot we could do in here. But one thing that existed a lot were log files. Logs all over the place, including one screen that allowed you to enter a freeform log file location. So you look up Etsy password, it gives you an error message because it's not a valid log file. All right. Etsy not a real file gives you a completely different error. Cool. So this is probably Red Hat. You can now start to use Burp Intruder or something. Start to enumerate all the files on the system. Try and figure out where they are, how the system functions, where different applications reside, things like that.
All right. So once we were done looking at HMC web application, we moved on to the second web application which we had access to, and that was DSCLI. Quickly, we noticed that DS8000 had a feature called DSCLI, which is IBM's own implementation of the DS jail shell. So you see a pattern emerging over here, right? So we already had good luck with poking at Dell's implementation of their jail shell, so it was a no-brainer that we had to look at this point. So the DSCLI web UI works in two modes. One is a simple single command mode where you enter a command, you get the output. Didn't have much luck breaking out of it in that mode. So it has another mode where you upload a file, a local file containing a list of DSCLI commands separated by new line. It executes that command one by one and gives you the output. So that was an interesting feature. So we tried to poke at that a little bit. So in the request over here, you see that we're using the DSCLI file input function call to upload a file called ast.sh. You can ignore the shebang line. It doesn't matter for this attack. All that matters is you see two commands, id and whoami separated by new line, and that file is uploaded to the temporary directory. And then you can call the execute DSCLI command gadget to point it to your file, temporary file on disk. And in the response, you see that it says error, id command not found. Observations over here, right? First of all, there were two commands in that file, id and whoami. id command not found, well, it errored out because id is not a valid DSCLI command. It's a bash command, right? But the other thing, whoami was never executed. So because the way it works is it executes one command at a time, and when it encounters an error, it prints out the command in question along with an error message. So keen observers will notice that this looks like a file read, but in a very limited fashion, probably the world's most limited file read. This is where you give up because you can't do anything with it, right? You can just read one line of a file. Doesn't make any sense, right? Turns out execute DSCLI command gadget runs as root, and now you can just point it to etc shadow. And what is the first line of etc shadow? It's the root password hash. And also, they never changed it, so we could crack a root password hash in like under 20 minutes. Do what you will with that information.
But not too much.
Also, if you guys have, any one of you over here has a DS8000 machine, change that root password hash. It's a wordless. I think it's a RockU password. So, all right. The other thing that we noticed is the remove script gadget. Well, it turns out that remove script gadget, the way it works is like you upload a file, you execute that command in the file, and then remove script is called, and then it deletes the file, cleans up the file on disk from temporary directory, right? Turns out that also runs as root. So now you can delete any file on disk as root. So to test our theory, since it's prod, we couldn't actually start deleting like files in Etsy, right? It doesn't make any sense. So what we did is we created a new user, and as soon as you create a new user in DS8000, it drops a file on disk like bashrc. So we confirm that the file is existing using the previous gadget, and then we call remove script with those arguments, and then when you try to read it again with the execute DSCLI gadget, it tells you that the file is not found, effectively deleting that file from disk.
So what was the impact of this? Without being seeded any access, we could get into 2 of the 3 applications with default credentials, enumerate all the files on the file system that we could, guess, read the first line of any of those files as root, and delete any of those files as root. I'm just going to go out on a limb and say we'd probably be able to cause some system outage. Don't know how bad, but just making an assumption that we could probably take down a system deleting the right files. Of course, we couldn't try it. It was prod. The challenges we had here were that we didn't have a non-prod environment. It was production only. We couldn't make any changes. And we felt that this was not a comprehensive test. We didn't feel confident saying we were done, but that was the end of our time, so we stopped there. We're sure that there's a possibility of more findings. If you've got access to a non-prod environment with DS8000, go for it. There's probably a lot more to find there. We reported it to IBM, and they fixed it early last month. We then moved on to AWS Backup. That is a service that runs in an account in AWS, uses the industry standard of compliance mode and retention lock. In our case, in our environment, it's running as part of an organization. So that's just a series of accounts set up in AWS that are all tied together in some way. Maybe each department, each team, each application will have its own account, all tied together to one organization so that you can maybe have one payment method for it. So not every team needs to pay for their own accounts with their own credit cards or something. In this case, we're just calling the POC backup. We're calling the account that we attacked POC backup, just for the sake of the talk.
All right, so for our testing methodology, by this time we knew that it wasn't worth it to attack immutability of data, but rather the entire architecture. And if you guys have worked with AWS or did any kind of pen testing on AWS, you'll soon realize that you either have the creds or you don't, right? And once you do get a set of creds, you cred shuffle, find a better set of creds, keep doing that, keep assuming roles till you eventually escalate your privileges to the desired level that you want. So that was our goal. Find creds, first of all, so that we could talk to AWS. Second, escalate our privileges, and then eventually get to the POC backup account in question and try to do some damage in there. So anything that talks to AWS was a valid target, and we were able to convince our stakeholders the same. So that would include the internal Git servers, Docker containers, container registries, any kind of automation that deals with AWS, right? So that's what we did. We started with from the perspective of an unauthenticated user with no credentials inside an organization's network. And we came across this container registry that allowed, there were multiple container registries, but this one particular one lets any user pull containers from it without needing privileges. And we found, lucky for us, because we found a container that had base64 encoded credentials for the Git admin. And using that, we were able to log into our internal GitLab server. And if you guys have your own GitLab instances out there, the admin area is a dead giveaway. Like, you can't access it as a normal user. You need to have admin privileges. So if you're here, we pretty much have compromised GitLab at this point. So our goal was to find out, usually devs, there's a good chance that they use some kind of automation for deploying in AWS, and the common one is Terraform. And that does happen through GitLab CI pipeline. So our idea was that we would end up identifying a privileged GitLab runner and somehow compromise it, get the creds out of it, and move from there. And from our research in the admin area of GitLab, we identified this privileged runner and the only thing of note over here is the tag. That's redacted, but the tag ending in runner. So the way GitLab works is if you try to execute your code using a CI file, by default, it's going to run on a shared runner. Shared runners are not privileged. They're not going to have anything important on them. So you want a privileged runner. And to ensure, once you've identified the privileged runner, to ensure that your code runs on that particular runner, you need those tags. You need to call the runner with those specific tags, else they're not going to run. So that's what we did. We created our own malicious repo. We uploaded our CI file on it. And for the lack of better words, this is the exploit code. So quick overview of a CI file or how to write a CI file. The stage section is not relevant over here. That's just what you need for it to execute. So you can just call the stage, instead of testing, you can call it prod. That's fine. It's a valid keyword. The other one is the tag section. That's the most important one, because here you can see the same redacted runner tag over there, because we want this CI file or the code inside the CI file to run on that specific privileged runner. And we downloaded, or what we're trying to do is we're using wget to download a statically compiled copy of curl and make a request to the EC2 metadata endpoint and grab the creds out of it. The creds for this account in this case is the one ending in runner prod. And soon in the CI log files, we discovered the temporary credentials as soon as the code ran. And from there on, it's pretty straightforward. You grab those, dump it in your credentials file locally, and you can authenticate with AWS CLI. And as you see over here, we are, let me get this. As you can see, we are in the ARN, or the account ending in 68, and we have assumed the role of this runner called as runner prod. So from here on, again, AWS cred shuffling, right? We have this set of credentials. We want better. We want something that can get us to a privileged account. And our goal is the POC backup account, the one ending in 57. So what we did is we started looking at it. This is a better screenshot from a different tool. But again, what we did is we identified, enumerated our privileges, enumerated other roles from cross accounts, and we came across this management role, right, in the POC account that we want to get into. And turns out our account from the 68, the one ending in 68, can assume role into it. Sweet. Well, that's good. Another thing that we noticed is the same management account also has the administrator access policy attached to it. And that is a default AWS policy, which gives you wildcard on all actions and wildcard on all resources. So you can just do anything you want in that account, right? Effectively compromising the POC account. All right, before we get to possible ramifications, I know it was a lot, and let's just do a quick overview of the attack flow. Like I said, AWS, you either have the creds or you don't. So in our case, we didn't. So our goal was to attack AWS as an unauthenticated user, which didn't make sense. You need creds to talk to AWS. So instead of directly attacking AWS, we tried to target the container registry, found unauthenticated container registry, got creds out of it, those creds turned out to be Git admin credentials, helped us compromise a privileged runner on GitLab, and eventually lets us pivot into AWS. So as far as ramifications go, the same the management role that I spoke about gave us enough permissions to assume role into a backup deployer role. You need that role in your AWS if you're dealing with immutable backups, because that's the role that deploys your backup policies. So tells us, oh, backup this database from this account to this immutable vault over a period of X days or whatever, right? So assuming role into that backup deployer role not only lets us like review those backup policies to see which data sets are being backed up, but also lets us manage them. So we could create new policies, we could delete the existing policies. And as far as monitoring goes, in our situation, we saw that no one was actually monitoring any changes to those policies, so we could just drop them, right? There was only like one person looking at it because they were the primary dev. So we took our findings back to the AWS team. They were happy with it, and but they did hit us back with by saying that all our changes, whatever we did, was not that big of a deal for them as far as cleanup goes, because they could just use their admin accounts, log in with their separate admin accounts that are deployed using SSO, they could just log in and run a CloudFormation automation job and just fix whatever we did in a matter of a few seconds, right? Not the thing you want to hear as an attacker. So so that's when we decided, okay, how can we log them out of their account, effectively ransoming, basically doing the same thing that we did with Dell. Soon we realized from our runner, we were able to enumerate enough privileges and assume role into an SSO delegation role, right? This is where it gets fun, because that role lets you control the deployment of the AWS admin accounts. So from that point, we could just delete their AWS admin accounts, effectively locking them out. And the only way they could undo the changes from that point in time would be to get access to the root principal. And in AWS, when you set up a new account, the first account that you get is the root principal. So use that, and it's a long and tedious process, but that's the only way you could do it from that point onwards. And also, as an attacker, which we didn't have to because we effectively got our goal away. This is where we stopped our exploitation attempts because we were happy with the results. But as an attacker, if you do come across the root principal by any chance, right, in a password vault or sitting in a plain text file somewhere or in someone's email, you could use that to delete the account. And the only way that you can recover this, like AWS does let you recover it, but the deadline for that is like 90 days since the time of deletion. So if that time passes, the account is not going to get recovered anymore, right?
So what recommendations do we have for all of the solutions that we tested? Change default creds. Come on, common sense stuff. But vaulting your creds, limiting access to who has access to those vaults, MFA, all the things, alerting and monitoring. If only 3 or 4 people on a specific team are meant to access something, have some alert when anybody accesses it. If those 3 or 4 people weren't the ones who were logging in, they now know that somebody's in their system. Probably a good thing to know. Keep your software up to date, obviously, right? Offsite backups, the 3-2-1 rule, and allowing your security researchers to test these solutions. Why might you want to include these in your attack landscape? Because, so in all 3 of these cases, we were told that recovery might be possible, but they'd have to get the vendor on the phone, they'd have to get some help, they might need to fly in some new equipment, they weren't sure. But if it's going to take longer than it takes just to pay the ransom to get back up to speed, then what's the point in having your immutable data? An out-of-the-box, untested, unpatched system might protect you against just general disaster recovery if an asteroid hits the data center, but it's not necessarily going to protect you from an attack where they're actively targeting your backups. So what we're saying is, if your data is inaccessible, is it really immutable? You shouldn't rely on vendors to test all of these solutions. You should be doing it yourself. If you have these solutions in your environment, you should make sure that they're secure and doing exactly what you expect them to do. Ultimately, these are just computers. They have the same issues as every other computer. They're more locked down. In some cases, they have very limited sets of commands, but they're still just computers. And it's fun to attack them. Some of the other solutions we found with a real quick Google search, Azure has an immutable solution. Google Cloud Storage has one. Oracle Veritas NetBackup, which we used as the restoration software, but they have their own solution. BMC for mainframes. There's a bunch more. There are so many more that we found. They all claim to have some sort of immutable solution. If these aren't being tested, we don't necessarily know that they're not susceptible to an attack and could be taken down. And then what good is having your immutable data if you can't get to it? So we think that these should be targeted and these should be tested and made sure that they're secure. So a quick timeline. We reported our finding to Dell in September of last year. They reported back to us. They reported to us a lot. They were really communicative. They got back to us with their fix in December, granted 1 CVE. And then the timeline for IBM was that we reported to them in October of last year, and eventually they rolled out their fix March of this year, sorry, so just last month. They granted us 4 CVs, including the developer tools one. So, all right, any questions? I had a professor say that all the time. I liked it, so I stole it from him. You know, borrowing. Yeah.
So I just want to buy a little fast.
Yeah.
In total, how many
So how many did we report and how many did they acknowledge? For Dell, we reported one and they acknowledged and fixed one, granted one CV. Same with IBM. We reported 4 and they fixed 4 and granted 4 CVs. So yeah.
Amazon's notoriously prickly if you test their stuff. What kind of response did you get out of that?
So we weren't doing, okay, so the response, what response did we get from Amazon or how we attacked them? And we didn't do anything to Amazon that wasn't a built-in allowed feature. Assume role is built in, it's an AWS thing. So we didn't do anything strange. The vulnerabilities we found for AWS were really in our implementation. So it wasn't really that we were attacking Amazon, we were attacking our implementation of it using built-in allowed functionality. And one more.
And as far as Amazon goes, you only get angry emails if you use their infrastructure for scanning, right? That's what we've noticed. So you spun up, use your EC2 instance as a C2 redirector, they're not gonna be happy, right? Or you use your EC2 instance to start port scanning other IP addresses. That's when you start getting those letters, and then you have to submit exceptions for it. All right. Anything else?